Hi guys, I am Muchakwa and I am back with Maths XYZ, and today I will be taking you through parabola functions. Parabola functions. The parabola that we will be talking about today is in the standard form of f at x is equals to a into x minus p squared plus q. So from this equation you must consider that a determines the shape of the graph. A determines the shape of the graph, and if a is greater than 0, then we will have a concave up shape of the graph, and as if it's a happy face. And if a is less than 0, then we'll have a concave down. So this is how the graph will look like if a is greater than 0, and if a is less than 0, it will look like that. It will be looking down, and that one will be a concave up. Then another thing that we must take into consideration is p and q, of which p and q, P is the x coordinate of our turning point, and Q is our y coordinate of the turning point. So P and Q from that equation determines the coordinate of the turning point. So another thing that you have to do is to find the x-intercept by making y is equals to 0, and also find the y-intercept by making x equals to 0. So, and another thing that you have to take into consideration is that if a is greater than 0, then the turning point will be the minimum value of the graph. As you can see from this one, a is greater than 0. This one, the turning point is the minimum value of the graph. So, and also if a is less than 0, then the turning point will be the maximum value of the graph, as you can see from the rough sketch that I've just drawn here. Alright, just a quick recap. As the parabola that we'll be doing today is the standard form of f at x is equals to a into x minus p squared plus q. Then a determines the shape of the graph, and if a is greater than 0, then we will have a concave up graph, and also the turning point will be the minimum value of the graph. Then if a is less than 0, then we'll have a concave down graph, and the turning point will be the maximum value of the graph. Then from the equation that we have, P and Q determines the coordinate of the turning point, of which P is the x coordinate of the turning point and Q is the y coordinate of the turning point. Now let's just do one question and see how we will apply this in a question. Alright, suppose we are given an equation f at x is equals to x plus 2 squared minus 1. Then remember, the parabola that we were doing today is that the standard form of f at x is equals to a x minus p squared plus q. Alright, then from here the first thing that you have to look at is a, as I've shown you earlier on, that a determines the shape of the graph. So from here we can see that a is greater than 0. That means that our graph will have a concave up shape, and also the coordinate of the turning point will be the minimum value of the graph. Then another thing that we have to take into consideration is the coordinate of the turning point, of which that is determined by P and Q. So from the equation that we have, we can see that P from this equation is -2, and our Q from this equation is -1. Alright, so these are the coordinates of our turning point. So the third thing that we must also do is to find the y and the x-intercept by making the other value 0. So if we have to find the y-intercept, we will then have to make x is equals to 0, and if we have to find the x-intercept, then we'll make y is equals to 0. Then okay, let's start with the y-intercept by making x is equals to 0. Then this is y-intercept, making x is equals to 0. So from that equation we will be left with it's f at x, f at 0, I mean to say, it's equals to 0 plus 2, that will be 2. So it will be 2 squared plus minus 1, sorry. It's 2 squared minus 1, which will be 4 minus 1, which will give us 3. So the coordinate of the y-intercept by making x equals to 0, it will be 0 is to 3. All right, then from here we just have to find the x-intercept by making y is equals to 0. So okay, if I can just make a space here. Okay, where can I make a space from? Here. These are the coordinates of the turning point. We'll look at them later. Then by finding the x-intercept by making y is equals to 0, we'll have x plus 2 squared minus 1, which will be x squared plus 4x plus 4 minus 1, and that will be x squared plus 4x, 4 minus 1, that will be 3. So if we factorize that, we'll have 3 and a 1, x and a plus and a plus. So the coordinate of our x-intercept, it will be -3 is to 0 and -1 is to 0. So the coordinate, the points that we have for this graph, it's our turning point, which we found -2 is to -1. It's our turning point. Our y-intercept, which is 0 is to 3. Our x-intercept, which is -3 is to 0, and another one is -1 is to 0. Now we can construct our graph. If I can just take this down. Okay. The points that we have for the graph, I'll just write them here for space. It's our turning point, which is -2 is to -1. Our y-intercept, which is 0 is to 3. And then our x, which is -1 is to 0. And another one, which is -3 is to 0. So this one is our first and this is our second. And we already know that our graph has to be a concave up because our a is greater than 0, and our minimum value, our turning point is our minimum value of the graph. Okay, from here we construct the graph. Remember, when you draw a graph, you must always make sure that you name your axis. So this one that I'm drawing here, it's our y-axis. Okay, let me just remove the heading for space. This one is our y-axis. This is our positive y-axis. This is our negative y-axis. Okay, from here then we can draw our x-axis, which is this one. This is our positive x-axis. This is our negative x-axis. Alright, from the point that we have, then this is our origin, which is 0 is to 0. We have 1, we have 2, we have 3 there. Then we'll have 1, we'll have 2, and 3 there. That's 1, 2, 3, which is negative, negative, and negative. This one is negative, negative 2, negative 3. Then our first point that we have is -2 is to -1, of which this is -2 of x, which is here, and -1 of y, which is there. So this is our first point there. This is our turning point. Then our y-intercept, which is 0 is to 3, it's right there. This is our y-intercept. Then our x-intercept, which is -3 is to 0, is this one, and this one is -3, -1 is to 0. Then our graph, we just have to connect the dots. It will go like that. Sorry. Okay, that means my tree should have been somewhere here. This is 3. So our graph will go like this. So this is not drawn to scale. I'm just showing you a rough sketch of how the graph will look like if you draw it. Then this one is our turning point, which is -2 is to -1. This one is our x-intercept, which is 1, number x-intercept 2, and then this one is our y-intercept, which is 0 is to 3. This is just a rough sketch of how the graph will look like. Remember to always just consider, if you are given an equation, you must just do the step by step. You must look at A, how the graph will look like after when you draw it. A determines the shape of the graph, and if it's greater than 0, then you know that your graph it will have a concave up shape, and if it's less than 0, then it will have a set face. Then another thing, you have to look at P and Q, which are the coordinates of the turning point. And also, if your A is greater than 0, you know that the turning point will be the minimum value of the graph, and if A is less than 0, you know that the turning point will be the maximum value of the graph. Then another thing that you must also do to draw this graph, you must then find your x-intercept by making y is equals to 0, and also you must also find your y-intercept by making x is equals to 0. Then when you draw your graph, you must always make sure that you name your x's and make sure that you do put the sign on your x's, like this is your positive y, positive x, negative y of your graph. Then after that, you would have constructed a good graph of the parabola function. Thank you. I hope you enjoyed today's session. Remember to subscribe to Math XYZ so that you can get daily notification when we upload videos. And if you have any question or comments, just put it on the comment note, then we'll have a follow-up on it. Thank you.